Hey guys, Mr. Ye here, and today we are going to cover the final section of Chapter 2, 2.7, which has to do with graphing inequalities. The good news is we've already laid the groundwork for this, so this should be a pretty easy, quick section. Just a couple things to add, some things you might have seen before. I'm going to show you something fun that you can do with a calculator to graph these inequalities and kind of help visualize them. But let's just dive right on in. So 2.7, graphing inequalities, specifically linear inequalities is what we're looking at right now, which is convenient because we've spent this entire chapter talking about linear equations. So we know how to graph linear equations. Inequalities will look something like this. Now, two questions as we're looking at this. First question is, what determines if we should have a solid line like you see on the right, or a kind of dashed dotted line like you see there on the, mix those directions up. Solid line like you see on the left, or a dashed line that you see on the right. And if you don't remember, a solid line indicates that we have a greater than or equal or a less than equal. Basically that we have an equal. It's kind of the line version of a closed dot, if you remember us talking about that. Closed dot means equal to, include that value. Open dot means don't. If we have equal to's when we're graphing these linear inequalities, solid line. And if not, if it's just greater than or just less than, that's where we have the dashed line, that dashed dotted line. The other question really is, how do we know if we should shade kind of below the line or above the line? And so this one is kind of intuitive. If it's less than or less than equal, we'll shade below. If it's greater than or greater than equal, we will shade above. So we're going to be looking at this. We're going to be seeing how to check them, how to graph them on a calculator. Let's dive right on in. Right here, just really quick, pause the video for 10 seconds, decide should they be solid or dashed, and then when you are ready, hit play again to see if you're right. All right, hopefully you had a chance to answer these questions. Greater than, dashed line, less than, dashed line, greater than equal, solid line. And then this fourth one is one of the reasons that I put this on the screen, to be honest, before we start graphing. What about if it's just equals? Well, when you think about it, we've been graphing equals for a long time, and how have we always graphed them? Always with a solid. It does follow that pattern of, if there's an equals, make it solid. This one just happens to be completely equals, no greater than, no less than, we'll make it solid. And then this final one, because it's less than or equal to, it will also be solid. So if we are going to graph, I'm going to just pretend it's an equation for the first few steps. Okay, I want to get it in slope-intercept form. That's how I like graphing. That's the most comfortable and most familiar way for me. So I'm going to turn this into slope-intercept form by getting y alone. 7y is greater than negative 2x plus 6. Notice I just carried that greater than straight down. I'm going to divide everything by 7. Y is greater than negative 2/7 x plus 6/7. Okay, so I got it into slope-intercept form, y equals mx plus b, except it's not equals, it's greater than. But I'm going to keep going on just as if this were an equation. So y is greater than negative 2/7 x plus 6/7. So I'm going to draw my y-intercept at about 6/7. I'm making an open dot because it's a greater than. There's no equal to, so I'm using open dots to graph this line. 6/7, and then I'm going to go up 2 and left 7. 1, 2, 3, 4, 5, 6, 7. Or down 2 and right 7. 1, 2, 3, 4, 5, 6, 7. Because my slope was negative 2/7, I know it needs to be a downhill line. And then grab my ruler and just graph this guy. Graph this guy. Hopefully my drawing was at least in the ballpark. It looks like I need to just tilt it a tiny bit more. It looks like it's in the ballpark. So then over on the right-hand side of the screen, you can kind of see where it says solid or dashed. Well, it's greater than, we used open dots. We know this needs to be a dashed line. So I'm going to draw that in, get rid of my ruler. Solid, or circle the wrong one, dashed. There it is. Okay, where should I shade? Well, we want to shade anywhere where y is greater than this line. So where are the y's greater than this line? Above the line. All right, step 4, final step, check 2 points. We've done this before many times, one that should work, one that shouldn't. So to start, for my one that shouldn't work, I'm going to check 0, 0. It's not shaded. It's like my favorite one ever to check. 2 times 0 plus 7 times 0. Is that greater than 6? Is 0 greater than 6? No, it's not. So 0 does not work. Sorry, 0, 0 does not work. And we didn't want it to. It's not shaded on our graph. Maybe I try this green dot that I'm drawing, and maybe I try 0, 3 and see if it works. Does 2 times 0 plus 7 times 3, is that greater than 6? 0 plus 21 is greater than 6. So it's shaded, it should work, it did. I'm feeling good about my answer. I tried one that should, one that shouldn't. Both were just as I expected. So before we leave, and I should say, this is our final answer. This right here is our answer. We don't write it algebraically, we just graph it for these linear inequalities on the coordinate plane. I want to show you how to graph this on your graphing calculator though. So I'm going to take out my calculator, I'm going to move it to the side so I can see my y equals equation. And I'm going to go to y equals and type in that equation. I'm going to say negative 2/7 x, that button next to alpha, but I forgot the 7, so negative 2/7 x plus 6/7. And if I graph this, it'll show me a line that looks pretty much exactly like what we have on the graph. Okay, great. That was y equals negative 2/7 x. What if I want to shade it? Well, if I come over here to the very left-hand side, I just hit my left arrow a couple times. If I hit enter now, you'll notice that it changed to a thick bold line. If we want to shade with a bold line, that's how we do it. If I hit enter again, it says, do you want me to shade above the line? And because we're dealing with a y greater than, yeah, that's exactly what we want. So I'm going to leave it there and hit graph. And now you can see a graph on your calculator that looks pretty much exactly like ours on OneNote, shaded above. The one thing the graph is not great at showing is a solid versus a dashed line. That's something you just got to know. That's why we did that extra practice above. So y is greater than, solid line. All right, so what did this come down to? Graphing a line, figuring out solid dashed, figuring out where to shade, and checking. I want you to try this second one. Pause the video, work it through, get y alone, graph, shade above, below, check 2 points. I'm going to work it out while it's paused, and then we will compare in just a second. So until then. Okay, hopefully you had a chance to work that one out. My work is on the screen. You can see I have a solid line, and it has a slope of 1/5, y-intercept of -2. One thing I do want to point out is I shaded below. Notice up here where I changed colors, when I divided by -5 on both sides, I did flip the sign. Now, if you forgot to do that, but you checked, you probably caught yourself. I checked 0, 0, it didn't work. I checked for -2, kind of this point right here that was shaded, and it did work, so I'm feeling really good about my solution. I also did put it on the calculator. I typed in that slope-intercept form, that y equals form. And then to see the shading, once again, I'll just come back here, go all the way to the left, and hit enter. I don't want a bold line. Enter, I don't want to shade above. Enter, I do want to shade below. And graph. And your graphing calculator can do that for you. So hopefully this is pretty much what you got. If you didn't, pause it, find what you did differently than me, see if I made a mistake or you made a mistake. Let me know if it was me so I can fix this video. But hopefully this one went pretty well. So last one, just one more. And if you look at this one, it's a tiny bit different. It is. We have absolute value inside of our inequality. So how are we going to handle this? Well, if you remember when we were talking about absolute value in section 2.6, last section, we said find the rebound point which is whatever we can plug in for x to make inside the absolute value 0, and then do a few to either side until we find that v. So I know that the rebound point is actually x equals 0, because whatever is inside the absolute value, we need to equal 0, and it's just x. So 0 is my rebound point. I can plug that in and say absolute value of 0 plus 1 equals 1. So 0, 1 is a point on my graph. What about, and I should do that in open dot because this is a less than, not a less than equal. So what about 1? What is absolute value of 1 plus 1? Well, that would be 2, which means negative 1 is also 2, and we could confirm that. Starting to see the v, I'll just do one more, 2. So absolute value of 2 is 2, plus 1 is 3. So 2 comma 3, negative 2 comma 3. We see our distinct absolute value shape. I'm going to go ahead and connect these dots, and I'm going to use a dashed line, right? Dashed line because it was just less than, not less than equal. So I'm going to dashed line all the way up that way, and then all the way up this way, or I might work my way down actually. Absolute value function is graphed. The inequality is almost graphed. We got our dashed line. It is less than. I'm going to shade below. And then finally, last step, let's make sure that we check 2 points. So 0, 0 should work in this case. I'll do it over here. 0, 0. We're saying is 0 less than or equal to the absolute value of 0 plus 1? And yes, it is, because 0 is less than the 1 we'll get on that right-hand side. Something that shouldn't work, maybe I try this point, which is 0 comma 3. So is 3 less than absolute value of 0 plus 1? No, it's not 3. It's not going to be less than 1. It doesn't work. We didn't want it to. And so it just gives us more confidence in our answer. Guys, hopefully this makes sense. Hopefully it's a little bit of review graphing inequalities. The calculator might be new, the checking answers might be new, but it's all pretty similar to stuff we've done before. If you have questions, write them down right now so that when we next meet, we can discuss them. But otherwise, that's all I've got for you today. I will see you guys next time.